Hi guys. So today we are going to solve this problem, palindrome partitioning, where we are given a string and we need to partition it such that every substring of that string is a palindrome. So to solve this problem, first of all, look at the constraint. So it is 16 at most. So with this, we know that we can even divide it into sub problems. And what usually happens there? We have a number of options. In this case, we can say give it, take it or leave it. And what will be the time complexity for that? It will be 2 power n. So is it possible to solve this in the given time span? It will be possible because it will be at max 2 power 16. And the worst case scenario will be where every string will be a palindrome string. Right. So let's look how we can solve this problem. So let's take this as an example. So we can see if this A is a palindrome or not. We know that every character by itself is a palindrome character. So we will just take whatever it is, and we can say, okay, this is the string so far, and whatever is left, we can treat it as a new problem. So in other words, we can say that this thing, the left part BA, BC, this thing is a completely new string for the same problem. And now, if we can go even further, we can say, okay, this B is also a palindrome, and again we can say that okay, this A, B, C is a completely different string for the same problem, and we can continue to do so. So here we can see if we keep doing that, then this is what we will end up with. So let's just dive in it. So we can see here we just took A and we just took this as a completely different problem. So we end up with this. Then again we took this B and take this thing as a completely different problem. Then again this, and again this. So what we end up with? Now we get that this A, B, and C, these all characters by themselves are palindrome. So this will be one of our answer. Now, as we did this, we can do same thing here. We can say, okay, this BA is it a palindrome or not? It is not. Okay, so BAA is a palindrome. It is also not, and this is a palindrome. And now we can just separate this C again. So when we have C again, we know that okay, so this A was a palindrome, and this also we just found out that this is also a palindrome, and then C, this C by itself is also a palindrome. So this is one of our answer. So first one we had this one, this the first one of all these, and the second one we got this one, this A, and then this B, AAB, and then C, right? Now again, we will see here that this AA is again a palindrome, and then this BC will be further divided into like this. Here we will have BC, and then we can divide this again into C. So this one. Now here again we can see we are forming another answer, which is A, then this B, then this AA, and then B, and then C. So that will be another of our option. And further, if we go further, then there won't be any other palindrome, as you can see. So we can come back here and we can check again. So if we are forming another palindrome or not. So if we take this, we have got this one, ABA. So this is also a palindrome. So this can be further divided. This we can take a different substring, and so we will have this ABC, which we can further divide to BC and then C. So that will be also one of our answer. So now let's go back and check our code for this thing. So here I have the solution for the problem. we were given this function partition to solve this. So we took this temporary vector of a string. When we will go down the line like this, we'll keep pushing all the substring which are palindrome. So we'll call this function DFS and take the length. And I will come back to this, what we are doing here. And we will run the loop here and we'll take the string so far. So the substring we took here, and then we'll check if this substring is palindrome or not. I've written this palindrome function here, and if it is palindrome, then what we were doing, we were taking the rest of the part as another palindrome, if it is a palindrome or not. So what we will do, we'll again call this function, DFS function, and pass rest of the string there. And we will keep doing so until we are at the end. So this is nothing but this is telling us if we are at the end or not. So if n will be 0, that means we are at the end. We'll just push it into the answer and then we will return it. So here's how you can solve this problem. So here the time complexity of this problem. Let's calculate what it will be. So we are running this for loop which will run to n. So there is n. So we can write here n, and from there we are we are using a recursive function. So as I've already told you, it will be 2 power n. So this will be the time complexity for our problem. And what will be the space one? So because we are running a recursive function, so stack is used there. So it will be n.